how a single circuit can be used to find a diode match finder, Zener diode tester and LED tester, that I am going to show you. And let us go to the circuit, and you have a 1 minute time. Copy down this. Only what we had done changes in this is the RL was there here, we have replaced by a diode, and we have connected a Zener diode, LED also, using a rotary switch, and remaining circuit is as it is. Even we have maintained a 100 ohm, 1 volt, the remaining circuit as it is. What changes we have made is just we have replaced a RL by a diode, and using a rotary switch we are connecting a Zener diode LED. So 1 volt what we have, and this side we have maintained the 100 ohm. Now can you type, anybody, what will be the current? Those who are active, those who are interested to learn, they can think and they can type. Last class I think we have discussed the same diagram, and you people have copied. Very good. Okay, 10 milliamps. Now we have a rotary switch. Copy down as it is, so that we will discuss. In the slide, if I take it as a 1 milliampere, then instead of 100 ohm, let us take it as a 1 kilo ohm. That's all. Because we have taken as it is from the book. So if 1 milliamp is there, then we'll change that to 1K. And just note down, through the rotary switch we are connecting the diode, Zener diode, LED. Hope most of you completed. So let me go to the next. Now let us consider a switch position is 1. I mean to say, hope you people can understand this. I'll zoom and I'll show you. This is a position, switch position, and you people can understand easily. And diode is connected. Let me go back and let me show you the path. Hope it is visible to everybody. Yeah, this is a path I am talking. Now think the switch is connected to the 1, and next time you think it is connected to the 2, later when I am talking about a Zener diode. Current is set by the Vin and R1. All of you know already, we have discussed in the previous class. Vin is 1 volt and R1 is a 100 ohm, and current will be 10 milliampere. What you have told just now, all the students, Sneha, Sahana, Divya, Siddhartha, Pavan, all of them, they have told it's a 10 milliampere. It is 10 milliampere is correct, and it is constant irrespective of whatever the diode you connect, because current depends on this resistor, this voltage. It is not depends on this particular diode what you are connecting. Now current will remain fixed. Diode voltage I have to measure. What I am doing, I am connecting 1 by 1 diode here. Say I want 4 same diode. Not physically, look, parameter I am checking. So same current is flowing. First diode I will connect. I will measure the voltage. V naught equal to voltage drop this plus voltage across the diode. Total will be V in plus Vd. V in is same. I am not changing. What I do, I will connect the first diode. I will measure the output. Second diode will connect. I will measure the output. Like that I will connect 1 by 1 diode. If I am getting same voltage, those diodes I will separate. That is the way how I can get a matched diodes. Your time starts now. Copy down, and circuit is with you. Only have to note down 2 important lines. I am connecting the diodes and I am measuring the voltage. If equal voltages are there, then those diodes I am keeping apart, separate. So those diodes are matched diodes. voltages I am measuring, and the voltages are same, VD. Remember the current is same, that's why I am saying if voltage is same, diodes will be same. This is the way how I can get a matched diode, which are useful for so many experiment where I need exact similar diodes for if I am connecting the fashion or in some other applications. That time I can make use of this circuit to find the matched diode. So let me go to the next. The same procedure I have to follow. So now instead of position 1, I am going for a position 2. Observe here. Position 1 was a what? Diode. Position 2, I have a Zener diode. This switch is, let us consider, connected to the 2. Current is same. This also I am not disturbing, therefore current is same. I am connecting a Zener diode, and one by one Zener diode will connect, and voltage I will measure. If voltage is same, then I can say matched Zener diode. So remaining all are same, only I have to note down 3 points. One is switch position is 2, and you are supposed to remember diode is fixed, current is fixed. Diode voltage I will measure, connecting one after the other. Just I will replace another diode. If the voltage is remaining same for a few diodes, those diodes are matched diodes, I can say, and I can make use of those diodes whenever I need a same Zener diode in a particular circuit. Only 2 lines you are supposed to copy. I take another 10 seconds to copy down. Zener diode is connected and voltage is measured. If voltages are same, then I can say those are matched because current is same. Similarly, if it is connected to the third position, I am talking about the second position. Hope most of you are observing it, movement. I am talking about this. And last, similarly, we can go to the third position. So third position, what I am doing? So third position, I am connecting LED. First position I have connected a rectifier, second as a Zener, third as a LED I have connected. Now current is remaining same. Now I am connecting a LED. So what I do here, brightness if it is same for the LEDs, those are, I can say, matched. So this is about a path what I am talking. I have shown you people already. This is a path you can observe. Let us consider the switch is connected to the third, and now you have a 1 minute. You can copy down hardly 2 lines or 3 lines. Current is same, circuit is same, voltage is same. Only the rotary switch position is third position, and I am observing not a voltage, I am observing the brightness. If I feel it may be difficult practically, but this is a application, even better may be available, or even some other methods may be there. Just how we can make use of this particular circuit for finding a matched diode, Zener diode, and similarly the LED. You have to understand. If the question comes, you should be able to answer in the exam. And not only that, where I can make use of these circuits later when you become an engineer in any industry, or when you are doing a hobby project, mini project, major project, you can make use of these things. Let us go to the next. Now we are supposed to discuss a current to voltage converter. I think current to voltage converter, whether you have discussed once. Let me ask you people, and it may be a delay little bit between your response and my question. Anybody can type yes sir, you have discussed, or no sir. Okay, nobody, they may be typing, there may be delay, but I am not getting anybody's name. Current to voltage converter. at least one or two students. I thought they may be regular in the classes. Okay, Preeti is telling no. Thank you for your response. Whether it's right or wrong, we'll see. Totashri, no, 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 no. Okay, thank you. And all of you are telling it's not discussed. Okay. Now, because others will say no. If 5 students say no, other students will say no. I want you people to go through the notes, whatever you have taken in the previous chapter, where you have discussed just glance once your previous notes. There may be a heading, a current voltage converter. That shows how much regularly you are going through. Anybody can see in your notes whether when we were talking about a feedback amplifier, that time we have discussed a current voltage converter. Anyway, I am going to thank you, Vinayak Damodar. You people should go through. Remember, Rakshita Kulkarni and other students also should go through. It is there. Remember, the studies are like this. I think most of you are using WhatsApp. If you do not see the WhatsApp for 3 days, even nowadays students will be always online. Say due to some reason 2-3 days you have not seen. Can you tell how many number of messages will be there? And is it possible for you to read those messages? Can you tell anybody 3 days you didn't see the WhatsApp? How many messages will be there in your WhatsApp inbox or whatever you say? Just type randomly. Okay, 3 days you have not at all experienced. At least 3 hours, 1 day, sometimes because of mobile was in repair, something. How many messages will be there? Within a day or 2 days, 3 days, somebody can tell. Why I'm asking this question? Very good. Ephraim, thank you. 300, I didn't understand. Is it a day or 1 week or 1 hour? I don't know, because it depends on the student or how many groups he is having. Sometimes I have seen in some of the group, late night I'm sleeping, and morning when I switch on, I'll be having say 80, 90 messages. When you see, we found that within one group, that much they have chatted. Sometimes it is difficult. Okay, 1000 plus in 3 days. Can you read those things? Which is very difficult. Remember, subjects are also like that, like a WhatsApp message. If you're not studying now, if you're postponing, it becomes a hard, which is very difficult. Even after 1 week, you won't get a time to read 1 week WhatsApp messages. Sometimes you will see only the personal messages, group messages you will delete. You won't having a time to read all those things. So you are so caring now about the WhatsApp messages. Why can't you care about your subjects? Because WhatsApp you cannot mention in your resume. But subjects, you can say you have studied, you have spent, this will give the job. So please think on that. The same slides what I have used previously, I am going to show you. This is already shown to you people. But you can note on the heading, because you people say, you have not studied at all, sir. You have not taught at all, sir. I have proof of each and every slide video. The timing I can mention, I can tell you. This is a time, this is a day, this is a video. Prove that I have taught you. But if you didn't listen, if you didn't learn, it is your life, your headache. Remember, everybody is having 24 hours. Some of the people, they achieve a lot of things in their life. How? We people won't get a time just to revise what is discussed in the last class. Leave it. Some work I want to do in the home. A little work, a small work. I won't get a time at all. But I don't know how others people are managing, those who are achieving a lot of things in their life. This is already there. Take a heading. and we replace the Vin and R1 by a current source In, the output voltage V0 becomes proportional to the input current. This we have discussed. These are all used in the sensing current from photodetector and D2A converter. Again, I am telling these things in detail. In the last unit, we are going to discuss in depth D2A converters. And tell you frank, they might have mentioned the 9 hours, it will take nearly 12 hours or more than that. The chapter is very huge and I want to spend more time on that chapter. That will be a 30% of your whole number of hours we have to spend, at least for the last unit. Earlier days I used to finish that first, then I used to come to the previous units. But this time anyway we are going according to the syllabus only. Let me complete this. Otherwise you have to discuss with another faculty. Again they have to convince the students. I thought of let me go like this only and let me complete. Anyway, this time it is online. Out of syllabus I won't get more time to discuss, and the portion will be completed usually online. Because it's very easy. We cannot see your faces. Interaction will be very less. So let me go to the next. Current to voltage converter. We have already taken this equation. V0 by Vin equal to minus Rf by R1. Therefore, V0 equal to minus Vin by R1 into Rf. So this is what we have discussed, the current to voltage converter. And one important is what we are going to discuss is V1 equal to 0 and V1 equal to almost equal to V2 we have discussed. Therefore, Vin by R1 equal to I. And V0 is given by minus I into Rf. What we want to say, the output voltage is directly proportional to the current because Rf is constant. V0 is directly proportional to the In. In is increasing, V0 will also increase. In reduces, V0 will also reduce because Rf is constant. So I can say it is a current to voltage converter. Just I'll wait for a few seconds. You people, either you can copy down or you can recall, or if you have some other duties to do it which are more important than this, you can do that also for another 40 seconds. Then I'll switch over to the next. During this time, if somebody want to tell something, they can type or they can unmute and they can talk. Remember, WhatsApp messages, whenever you are seeing, subjects are more compared to that WhatsApp messages. Every day 4-hour class, and to revise that, to go through that, you need more time. And it is just like I told you, WhatsApp messages. If you do not go through, it will be a cumulative and automatically it will become huge after some time. So let me go to the next. Now a last part of this unit is an integrator and differentiator. Hope integrator video I have already uploaded in the YouTube. Again, let me ask you, how many of you have seen that integrator video from the YouTube? Either mine or somebody's YouTube video. Just type, sir, I have seen. Don't wait for others to type. Because whether you have seen or not, you know. If you have seen, you type, yes, sir, I have seen. Otherwise, I will wait for another few seconds, then we'll continue. Okay. When the facilities are more, students will never study. This I am observing. Earlier days, we never used to get books. Notes, we used to go to the other college and we used to take a Xerox of Xerox. Sometimes it may not be visible properly. Again, we used to write it on that only so that it will become visible. But nowadays, in your mobile it is available. Integrator, if you just click, even the syllabus has shared with all your classmates. I think it's 4 representatives. And I'm sure those students have shared the whole syllabus with you people, and any syllabus, any subtopic, if you click it, YouTube video will open. And how many hours you are spending on your mobile? Keeping that in the mind only, I have created that PDF file so that my students, along with the WhatsApp, along with the other misuse of they are doing in the mobile, let them make use of a mobile for a study, at least a few percentage, at least 1 or 2%. Let them study in the mobile. There's a reason, but this discourages the teachers. Nobody has seen the integrator video, even though it is there in your experiment, and some students might have done the experiment. Let me ask you the question: how many of you have done the experiment integrator? Just type. I won't ask you the question. Anybody has completed the integrator experiment? Somebody had done it in my batch only. Thank you, Rakshita. Integrator. Some student has told they have completed. Vinay Kumar, Totashri, Shreya. Thank you, all of you. Basava, Amog, Pavan, Shreya. Okay. So hope most of you have done the experiment and most of you might have understood. And Manchunatha, Siddharth. Very good. And why you are supposed to go to the lab? Why you have to conduct the experiment? This also I have told in the class many times. Remember, you are not going to the lab just to show that output to the teacher. Whether you are showing it to the teacher or not, you should first see the result, and if a result is coming, you should be able to understand why you are getting. If you won't get a result, you should be able to check it, why you are not getting the result. Please take serious. I can understand at your age it is very difficult. Even parents will be telling, be serious, concentrate on your studies. It is difficult at your age, but those who can do it, definitely those people achieve something. They will definitely do a good things. I have seen in this class also, few students are so active. I'll be happy to talk to them anytime. I'll be happy to help them. I'll be happy to learn from them also. A few students are very active, very serious about their future. But most of students, like at that age, they'll be very casual. They'll be not taking serious. Anyway, let me go to the integrator. Let me finish the integrator today at least. Before that, these are the suggestions. And do your project. It doesn't depend upon the guide. You people don't depend on the guide. Don't say, my guide is not asking, why should I do? Remember, after engineering, guide will never come in with you. I'll tell you a small incident which has happened. Hope all of you will be active when I say out of syllabus. One batch was there. They were doing under somebody in our EMC department only. And I used to tell them, this is not a work project. Either change the project or do something extra so that I can consider I can give the IA marks. I was in the team, a committee. Every 15 days I used to review that. 4 batches were there. And one batch was this, what I am telling. And every 15 days I used to scold them, and they used to become angry on me. And they used to say, no sir, we'll do it. Twice, thrice they did it like that. And eyes were there. Sometimes it was cancelled, sometimes it was postponed. So at the end, they didn't do anything. Very small project, they did it somehow. But anyway, a teacher has given the very good IA marks, that concern guide. Students were so happy. Wow, Virakman sir was there, then he would have made us to cry. That review process only, that IA marks, let him take how much he is having. And they were happy that they got good marks from the teacher and they completed engineering, they went. And after a year or so, one of the student came to the college, and in the corridor I was talking how all of you are there and whether I handled the lab or not. I don't know why I'm remembering your face. Your face is very known to me. That time that girl told, no sir, you not handled any labs, but used to review our project. Then I could able to recall, yeah, oh, yes. And she started laughing. And I asked, why are you laughing? No sir, I recall that project. Yesterday only we talked more about that. Okay, anyway, now you have already completed engineering. What incident has happened? Can you share with me? She told, oh, okay sir. Yesterday one of my project mate called me and we were discussing, and he told that incident. Just I'll tell you. That guy went to the interview and he completed the written test. He was so happy that he has cleared one round. It was off campus, because he couldn't get placed in the on campus. Off campus, he cleared the written test. He went for the interview. And when you go for an interview, especially in the offline, you are supposed to go with your project report. And he went with the project report and all other originals and all. And he sat in front of a person who was taking an interview. Then while talking, that person asked what project you had done in your final year engineering. This guy shown the report. A person who was asking a question or who was interviewing, he saw this report and he told, oh, this project, even my son is doing this project. Please listen 1 minute carefully. That person who was taking interview told to this my student, alumni, hey, my son is doing the same project. Then my student asked, oh, your son is doing any engineering, sir? He told, no. Then this student asked, oh, he's doing a diploma. That person told, no. Oh, then he may be doing ITI, something like that, sir. That person told, no. Then, sir, a person told, my son is studying in SSLC. I repeat, my son is studying in SSLC. He is doing this particular project. What he had done, one line was enough to reject that person. Guide will never come into picture. Remember that. Just imagine these 4 students, they took a 1 year, final year project. They spent 1 year to do that project, and an interviewer who was there, his son, studying in SLC, was doing the same project. How do you expect that this person should be recruited in the company? So that time he cried. He made a telephone call to this girl and told, Virakkumar sir used to tell, I used to curse him, I used to become angry on him. Today I realized. He told to that girl and that girl told to me. So please don't depend on your teacher. Don't say, my guide is so good. He gives a signature wherever I want, wherever, how much marks he gives. No, those will never help you. And not to say any reasons. There was a lockdown, sir. We were in different position. No. Start preparing for the GATE exam. GATE exam is very important, whether you want to do higher study or not. Simply you can plan GATE exam, write down. Even it is helpful for your recruitment. Sir, if I do not crack the GATE, if I simply prepare, it's a waste, no sir. Some students, without return, they never do anything. For such students, if you prepare for the GATE, at least it helps you to get a job in the core company. At least to get a job in the core company, even though you couldn't crack GATE. Sir, if I crack the GATE, क्या होता है? Government job will get. Without interview, you will get a government job. And servants will be there. And car will be given to you. Bungalow will be given to you. Wife you have to take, or life partner you have to choose. They won't give. Remaining all the facilities they give. And salary will be put in your bank account. After giving all the facility, petrol charge, that, this, everything they will give. And after that they will give you the salary. That salary you never touch. It will be always there in your bank. And do the simulation of all the experiment for all the labs, not only LIC lab, communication lab. Remember, whatever you do, it is for you, not for any teacher. This should come in your mind. And at this stage, it is very difficult. I too can understand. But if you do it, definitely it will be helpful to you. Try to improve your ENC basics. Whatever you are studying now will be helpful for studying higher semester subjects. Your DSP, if you are talking, if you know signals and system, it is good. VLSI, if you know network analysis, operational amplifier, some of the subjects, if you know in depth, VLSI will become AC. Don't think VLSI is an entirely different subject. Tell you frank, so many circuits what you have discussed now, you are going to design in the VLSI. They are also going to discuss the same current mirror circuit, etc. All those they will discuss in the VLSI. And improve your programming skill. Nowadays, if you are having a very weak programming skill, it will be difficult to get a job. Even if you get a job, it will be difficult to survive there. And take care of your health also, physical and mental also. If you are doing any habits, reduce it or make it or stop it doing that. Control your mind. Never allow your mind to control you. If possible, do the pranayama daily. Some of the things I told you out of syllabus, but it helps you people to become a good citizen of India. Take a 1 minute, just glance once so that you can continue the integrator. If anybody want to ask something, you can type in the chat box. If I know the answer, I'll tell you. If I don't know, I'll arrange a talk. You people can come forward. Sir, how to prepare for a GATE exam? I think one of your alumni has taken a lot of time to discuss how to prepare for a GATE exam. Usually I arrange not for all the students, those who are working with me. For 10 to 15 students that I arrange. And anything, how to do MS, how to do GATE exam, how to do competitive exams, bank exam. Many students are working in that particular area. You people can take use of them. And if you are really serious, even I too can help you people. And I can share their cell numbers, and you people can talk to them. You can interact to them. You can get a lot of information from them. No, sir, I want to do MS in US. Many students are in US are there. Some are in Australia. Some are in Netherlands. Somebody is in Germany. So Germany are many are there. So you can plan now. Only you can start building your basics strong. Let me go to the integrator. So most of you are, I don't know, done the experiment, but how much you have understood, I don't know. Please go through the video what I have uploaded in the YouTube. Again, the same thing I am covering here also. A circuit performs the integration to the input waveform. If I am giving a square wave, I will get a triangular wave. Circuit is inverting amplifier basically, but we used to write RF by R1. RF used to connect, but now here I have connected a element capacitor. V1 equal to 0, therefore V2 equal to 0. Reason we have already discussed many times. It is a virtual ground. Current II equal to 0. Why II equal to 0? The reason is op-amp input impedance is infinity. That current inside op-amp is 0. Hence whatever is flowing I1 will remain same, IF. And I1 equal to given by V in minus V2 divided by R1. As V2 equal to 0, what I get? I1 equal to V in divided by R1. We can copy down this two lines and the circuit diagram. I1 equal to V in divided by R1. IF is the current through the C. All of you know the current through the capacitor is given by C dVc by dt. Vc is the capacitor voltage. It is given by voltage drop these two. V2 minus V0, but V2 is 0, hence IF equal to minus C dV0 by dt, and I1 equal to V in divided by R1. Copy down the equations. Let me wait for another 10 seconds and then I'll go to the next slide. And please do the project, prepare the report, discuss with your guide, or if guide is not helping, discuss with somebody, a senior or a well-wisher. At the end, what you have learnt, that matters. All of you will face a problems, definitely. That is a step to learn. That is a step to learn. Let me go to the next. Just now we have discussed IF equal to I1 equal to. Apply a KCL to the inverting terminal. Then integrating both sides. These things we have discussed already. We in I1 equal to IF we have discussed. Why? Again the same thing we have repeated. II equal to 0. Just I1 I have written, IF I have written, and now I am taking integration both sides. I am writing, that's all. Steps are very simple. Whatever is there for this integration I am taking, for this also I am taking integration. So this becomes 1 by R1 into C and V into dt. This will become V0 by dV0 and integration I am taking. And now this is the differentiation was there. Okay. And now V0 of t, and usually initial capacitor voltage we assume 0, it will be 0, and further this is the one assumption we do it. Hence the output voltage given by minus 1 by R1 into C integration Vn into dt, assuming the initial capacitor voltage is equal to 0. Copy down this. The steps are very simple. Don't ask ये कहाँ से आ गया. It is there. Just now IF. These values were there in your notebook. Simply have copied, replaced, and took integration, and assuming a capacitor voltage, initial voltage equal to 0. The way how you used to do it in your network analysis. Initial capacitor voltage 0 you used to take. Similarly, we can do it for a differentiator also, and it is a homework to you people. Do like this only for a differentiator, and somebody can prepare a very nice video the way better than me what I have done, integrator. I'll be happy to upload that differentiator with your name only in my YouTube channel. Or if you want to do something, or if you want to help me to improve something, I'll be always happy to learn from anybody in the world. So it's the same slide, I repeat it. No change. And integrator output. Input if I give a square wave, then output will be a triangular wave. Input if I give a sine wave, output will be a negative cosine wave. I have this hope you can take 10 seconds or 15 seconds to copy down. It may be there in your notebook already because you have done the experiment. You observe the output by giving the input. I have taken a little 2 to 3 slides to explain how we'll get a triangular wave. This is not available in the book. I think more than 25,000 students have seen across the world. They appreciated these 3-4 slides because that is not given in the book. They explain like this only mathematically, but using a charging discharging they won't discuss. So practical integrator, if a small noise is there at V2 and V0 will go to the saturation because it's like open circuit, it blocks the DC. So to avoid that, the resistor is connected across the capacitor. This I think we have done in our lab also. This is one point which you have to remember. And input is applied. Try to understand. Input is applied here. Capacitor starts charging. Capacitor C starts charging. This is a path. Just keep your mind 1 minute in the slide. Understand. Then output is measured between the V0 and the ground. And V2 is a virtual ground. Output voltage increases in negative slope, depends on the RC. I am measuring from this point and this point. Actually, this point and this point I am doing. It's nothing but this point and this point, both are same. When it is charging, this will become a plus, this will become a minus. Observe this carefully. This becomes plus, this will become minus. And whatever it is charging is increasing is nothing but negative is increasing for me. Hence, this negative is appearing here. Observe this carefully. And now when charging is up to a T1 period, because up to T1 period it is a positive was there, therefore charging is there. After T1 what will happen? Input voltage suddenly changes to negative. It has become suddenly negative. Now capacitor cannot go suddenly a negative or opposite polarity. First it has to discharge, then it should go to the positive. But here the RC time constant is same. How much it has charged, na? Only that much it will discharge, because this T1 is equal to T2. Therefore, it reaches the 0. That time suddenly it will make a positive. That time again it will start increasing in the negative. So capacitor cannot change its polarity suddenly. It has to discharge to 0 first. Then should change the direction. This is a very important point you have to remember. Then it will change the polarity. And now the capacitor starts discharging when it reaches the 0 at T1, which is equal to T2. I am talking about this. Input again changes to plus Vsat. Input again changes to plus V saturation. This cycle repeats. That's why this square wave is converted into like a triangular. But remember, this line is very important. Most of the students, they write the line here in center gone case. They may argue with the teacher, hey, I also written triangular, na? And even in the interview also they will ask you to write an input and output, how it converts. Simply the students will write square wave, they write a triangular. This line they put at the center, which is dangerous. Please try to understand this concept. And if a T2 becomes greater than T1, then V0 voltage becomes positive. If this is more, sir, then it will cross the 0. This, when you are conducting the experiment, you have to change the duty cycle. You can make, instead of 50%, something. So if you make T1 less, T2 more, this will cross the 0. That should be observed. Anybody has observed that? Anybody has observed that? I'll be happy to see their names. Sir, aisa hua tha, maine try kiya tha. So we people will be very happy to see that. Any names? I'll be observing the chat box parallelly. This is the same slides I have taken, what I have given in the YouTube. You can just imagine how much pain a teacher is taking to prepare all these slides. And even as a human being, in general, any video you take, they might have taken a lot of pain to upload. Many people simply they dislike, without understanding how much pain they have taken to create that video. And many people won't bother at all. For them only they might have uploaded. Those people won't bother. I uploaded for my students, but lakhs together other students are seeing. You can see my YouTube videos, number of views. It has lakhs together it is. Subscribers, thousands together. But my students will be very less. Sometimes we feel very bad. But anyway, I am doing my duty perfectly. Whether to take or not, it is left to you people. Even many students might have not subscribed from this class also. But anyway, if you are not interested to see my videos, at least you can share that video with your classmates, those who are studying in some other college or other division students. Those who are interested, let them interact with me. Let them ask the question either offline, online. If I happy with the students' work, not performance. Performance, somebody may be intelligent, somebody may be very weak, but if I am happy with their effort, work, I allow them to talk to me at any time. And don't simply send any messages to my WhatsApp number, but if you are working, if I am happy with your work, always I reply. In your class also few students are there. They usually send messages to me, I reply to them. Even more than them, I type more because I love those students. Reason is they work. Those students, those who are working, I definitely like to spend my time with them. Today morning, Gulvesh was there. Only 4 people were there. Even I asked him to unmute and talk to me because I am happy to talk to those students, those who are so active in learning process. Being a teacher, we love those students. Thank you. And I think next is integrator frequency response. This you have taken already in the lab. That circuit will not work as an integrator for 0 to infinity range. So it depends on the RC value what we are using. This also you have already copied in your lab. If you want in detail video, even the reference I have given from where I have copied detail about a FA and FB. This portion actual response of a practical integrator you will get here, and ideal response of a practical integrator. This is what we have need. Okay, and similarly, and equations are there for FA and FB. Directly they are given in the book. You people can just remember based on the R1 CF and RF value, you will get FA and FB. Depending upon your requirement, you can choose a particular value so that you will get a integration of your input signal for a particular frequency. And these things are there with you already, and it is from the book snapshot I taken. And just to take this from book and keep it on the slide take a time for us, and you have to put an effort. And for you people who are doing it, at least you should appreciate when a teacher is uploading a lot of videos for you people. At least you should like that. Motivates him. Definitely will try to give more to the next generation. Differentiator is like when you compare to the integrator, hardly a difference is R and C positions you have changed. That's all. Remaining is same. A lot of videos are there on the differentiator also. And integrator has spent a lot of time. Similarly, the differentiator you have to study is a homework for you people. It's the end of the chapter. And today's class will conclude now. Thanks for attending the class. Take care and thank you.